Hi everyone, welcome to our physics class. In the previous class, we have studied about conservation of energy in LC oscillations and average power over one complete cycle in LC or series circuit. What is the expression for average power over one complete cycle in LC or series circuit? That is P is equal to VRMS, IRMS, cos phi. What is the meaning of cos phi? Cos phi is a power factor, right? So this is the last part of alternating current part 10. Okay, well, so let's start today's class. So first, let us discuss about watt-less current and watt-full current. This is very simple statements. So watt-less current means current flowing through a circuit containing only capacitor or only inductor. That is watt-less current. So what is the meaning of watt-less current? Current flowing through a circuit containing only capacitor or only inductor. So for example, current through capacitor current through capacitor or inductor. Okay, actually for purely capacitive circuit, what is the average power? The average power over one complete cycle for a purely capacitive circuit. For purely capacitive circuit, so that is equal to 0. That means for purely capacitive circuit, there is no power loss takes place. Okay, so current flowing through a circuit containing only capacitor, that is wattless current. Current flowing through a circuit containing only inductor, so that is also wattless current. For example, current through capacitor or current through inductor. So watt full current. Watt full current means current flowing through a circuit containing only resistor. Okay, so for purely resistive circuit, what is average power? That is not equal to 0. That is the product of RMS value of voltage and RMS value of current. So watt full current means current flowing through a circuit containing only resistor. So for example, current through resistor. Okay, so what is the meaning of wattless current? Wattless current means current flowing through a circuit containing only capacitor, or current flowing through a circuit containing only inductor, that is wattless current. For example, current through capacitor or inductor. What is the meaning of watt full current? Watt full current means current flowing through a circuit containing only resistor. Current flowing through a circuit containing only resistor, so that is watt full, because there is a power loss takes place across a resistor. When AC voltage is applied to circuit containing only resistor, that is actually called the purely resistive circuit. For purely resistive circuit, the average power over one complete cycle is the product of RMS value of voltage and RMS value of current. Even the power loss is also the product of RMS value of voltage and RMS value of current. So maximum power loss takes place across a purely resistive circuit. So that is why current flowing through the circuit containing resistor, that is watt full current. Okay, so what is the meaning of watt less current? Current flowing through a circuit containing only capacitor. Because for purely capacitive circuit or for purely inductive circuit, there is no power loss takes place, right? Actually, power is measured in terms of watt. Watt less means there is no power loss takes place. Watt full means there is a power loss takes place. Okay. So what is the meaning of watt less current? Watt less current means current flowing through a circuit containing only capacitor. That is watt less current. Okay, because there is no power loss takes place across capacitor. Or current flowing through a circuit containing only inductor. That is also wattless. Why? Because there is no power loss takes place across the inductor. So what is the meaning of watt-full current? Watt-full current means current flowing through a circuit containing only resistor, that is watt-full current. Because there is a power loss takes place across the resistor, right? So what is the meaning of watt-full current? Current flowing through a circuit containing only resistor. What is the example? So the example is current through resistor, right? Okay, so the next concept, that is transformer. This is very important. Transformer, that is actually a device. So this device is used to vary the AC voltages and hence the current. Device used to vary AC voltages, that is transformer. What is the meaning of transformer? Transformer is a device used to vary the AC voltages. Transformer, it is a device. It is a device used to vary AC voltages, AC voltages, and hence currents. Okay, transformer actually works on the principle of transformer. What is the principle behind the working of transformer? That is mutual induction. Mutual induction. So this is the principle behind the working of a transformer. What is the meaning of transformer? Transformer, that is a device that is used to vary the AC voltages and hence currents. It works on the principle of mutual induction. What is the meaning of mutual induction? Whenever the magnetic flux linked with a coil changes, EMF induced in the same coil, that is self-induction. The phenomenon of EMF induced in a coil, that is due to rate of change of current in a nearby coil, that is mutual induction. Okay, so actually choke is a device which works on the principle of self-induction. So transformer is a device which works on the principle of mutual induction. The principle behind the working of choke is self-induction. The principle behind the working of transformer is mutual induction. What is the meaning of mutual induction? The phenomenon of EMF induced in a coil, that is due to rate of change of current in a nearby coil. For example, the EMF induced in the secondary coil due to rate of change of current in the primary coil. So that is actually a mutual induction. So this is a principle behind the working of transformer. So actually transformer, so that is of two very important types. One is step up transformer and another one is step down transformer. Step up transformer and another one is the step down transformer. So step up transformer actually converts the step up transformer that is a device which converts. mm, so this is actually step down. So what is this? This is step down transformer. This one is step up transformer. Okay, step up transformer, that is a device which converts the low alternating voltage at higher current into high alternating voltage at lower current. Simply, step up transformer increases the alternating voltage by decreasing the alternating current. Actually, input power, that is equal to output power, but the voltage and current both are here variables. Okay, so what is the meaning of step up transformer? That is a device which converts low alternating voltage at higher current. Actually, this is the primary voltage. So this is the primary current. This is secondary voltage, and this one is the secondary current. So these are number of turns in the primary coil. This number of turns in the primary coil. So these are the number of turns in the secondary coil. So in step-up transformer, the number of turns in the primary coil, that is less than the number of turns in the secondary coil. Okay, so VP means the primary voltage. Look at this graph. So actually this is the time varying primary voltage, and this one is a time varying secondary voltage. Okay, so actually here the secondary voltage, that is more as compared to the primary voltage, right? So what is the meaning of step up? Step up transformer, that is a device. Step up transformer is a device which converts low alternating voltage at higher current into high alternating voltage at lower currents, or simply it increases the alternating voltage by decreasing the alternating current. Okay, step up transformer increases the alternating voltage by decreasing the alternating current. So what is the meaning of step up transformer? Step up transformer. Step up transformer is a device which increases the alternating voltage by decreasing the alternating current. Okay, so this is the definition of step up transformer. Step up transformer is a device which converts low alternating voltage at higher currents into high alternating voltage at lower currents, or simply it increases. Step up transformer increases the alternating voltage. It increases the alternating voltage by decreasing the alternating current. But step down transformer, so this is a device which converts high alternating voltage at lower current into low alternating voltage at higher current. This is IS, this one is VS, secondary voltage, and this is secondary current. So actually, in step down transformer, the primary voltage is maximum. Look at this graph. This is time varying alternating voltage in the primary coil and also in the secondary coil. Okay, so this curve shows the time varying alternating voltage in the primary coil, and this curve shows the time varying alternating voltage in the secondary coil. So actually here secondary voltage is less as compared to the primary voltage. So in this case, the number of turns, so this is number of turns in the primary and this one is the number of turns in the secondary. So here the number of turns in the primary coil is more than the number of turns in the secondary coil. So this is step down. Step up, it increases the alternating voltage by decreasing the alternating current. Step down, it decreases the alternating voltage by increasing the alternating current. Right? What is the meaning of step down? Step down transformer, it decreases the alternating voltage, decreases the alternating voltage by increasing the alternating current. Okay, step up transformer, it increases the alternating voltage by decreasing the alternating current. Step down transformer, it decreases the alternating voltage by increasing the alternating current. So these statements are very important. So what is the meaning of transformer? Transformer is a device used to vary AC voltages and hence currents. So what is the principle behind the working of transformer? Mutual induction. What is the meaning of mutual induction? The phenomenon of EMF induced in the secondary coil, that is due to rate of change of current in the primary coil. That is mutual induction. The device which works on the principle of mutual induction, that is transformer. So the device which works on the principle of self-induction, that is choke. What is the meaning of self-induction? Whenever the magnetic flux linked with the coil changes, EMF induced in the same coil, that is self-induction. Mutual induction means the phenomenon of EMF induced in secondary coil, that is due to rate of change of current in the primary coil, that is mutual induction. So transformer is a device which works on the principle of mutual induction. So transformer is of two very important types. One is step up transformer and another one is step down. Step up transformer and step down transformer. So what is the meaning of step up transformer? It is a device which converts low alternating voltage at higher current into high alternating voltage at lower currents. Or simply it increases the alternating voltage. Step up transformer increases the alternating voltage by decreasing the alternating current. So what is the meaning of step down transformer? It is a device which converts high alternating voltage at lower current into low alternating voltage at higher currents. Or simply it decreases the alternating voltage by increasing the alternating current. Okay, right? Okay, now let us discuss about construction, working, and theory of a transformer. So this is very interesting. The construction, working, and theory of transformer. So first let us discuss about the construction. Okay, so now look at this diagram. Actually, transformer consisting of two separate coils of insulated wire, but both are wound on the same iron core. It consisting of two separate coils. Okay, so these are the two separate coils. So these are two separate coils, right? So both are wound on the same iron core. So and then one of the coil, that means this is actually called the primary coil. So that is connected to the AC input. Okay, so one of the coil that is connected to the AC input. What is this? This is AC input, and this coil is called the primary coil. This is the primary coil, and other winding, it means other coil that is giving output. So this one actually giving output. So this is actually the primary voltage, and this one is the secondary voltage. So the construction is very simple. It consisting of two coils. One of the coil that is connected to the AC input that is applied to one of the coil. So that coil is called the primary coil, and another coil that is giving output. So that one is uh, connected to the load. Actually, this is load which gives the secondary voltage. Okay, so both coils are wound on the same iron core. So this is about a very simple construction of transformer. It consisting of two coils. So both coils are wound on the same iron core. One of the coil that is connected to AC input. Okay, so that is called the primary coil, and another one that is giving output. So this is connected to the load. So actually here we will get the secondary voltage. So this is the construction of transformer, and working is very simple. Actually, it works on the principle of mutual induction, right? Now look at this animation. So AC voltage that is applied to the primary coil. AC voltage that is applied to the primary coil. So what happens? The current flowing through the coil that is gradually increases. Okay, so if we apply AC voltage to the primary coil, what is this? Primary coil. So if we apply AC voltage to the primary coil, the current flowing through the primary coil that is gradually increases. Is it not? If we apply AC voltage to the primary coil, current flowing through the primary coil that is gradually increases. So what happens to the magnetic flux linked with the secondary coil? If current flowing through the primary coil is gradually increases, so the magnetic flux linked with the secondary coil that is also gradually increases. Okay, if current flowing through the primary coil is gradually increases, so then the magnetic flux linked with the secondary coil, so that is gradually increases. That means the magnetic flux linked with the secondary coil changes, that is due to rate of change of current in the primary coil. Is it not? If AC voltage that is applied to the primary coil, what happens? Current flowing through the primary coil that is gradually increases. So if current flowing through the primary coil is gradually increases, then the magnetic flux linked with the secondary coil, so that is also gradually increases. The magnetic flux linked with the secondary coil increases, that is due to the rate of change of current in the primary coil. So whenever the magnetic flux linked with the coil changes, EMF induced in the coil. Okay, actually here the magnetic flux linked with the secondary coil will changes. So that is why the EMF induced in the secondary coil. So EMF induced in the secondary coil, that is ES. ES is EMF. EMF induced in the secondary coil. ES or VS. VS is the secondary voltage. VS or ES. That is the secondary EMF. So whenever the magnetic flux linked with the secondary coil will changes, EMF induces. Actually here the magnetic flux linked with secondary coil will changes, that is due to the rate of change of current in the primary coil, right? So this is about the working of transformer. So the working construction of transformer both are very simple. So what is the construction? It consisting of two coils. One of the coil that is connected to AC input, that is called the primary coil. Okay, one of the coil is connected to AC input, that is called the primary coil. Actually both coils are wound on the same iron core. Okay, so another coil that is actually giving output. Okay, so this is called the secondary coil. Both coils are wound on the same iron core. Same iron core. So this is the construction of transformer. The working is when AC voltage that is applied to the primary coil. So what happens? The current flowing through the primary coil is gradually increases. If current flowing through the primary coil is gradually increases, then magnetic flux linked with the secondary coil, so that is also gradually increases. So whenever the magnetic flux linked with the coil changes, EMF induces. Actually here EMF induced in the secondary coil, that is due to the rate of change of current in the primary coil. So finally we will get the secondary voltage across the secondary coil. So EMF induced across the secondary coil, that is represented as ES. ES is EMF induced across the secondary coil. Okay. So this is about the construction and working of a transformer. And now let us discuss about the theory. So theory is also very simple. Theory of the transformer. So according to Faraday's second law of electromagnetic induction, according to Faraday's second law, according to Faraday's second law of electromagnetic induction. So EMF induced in the secondary coil, so that is represented as ES, or EMF induced in the primary coil, that is EP. EP, that is equal to VP. Both are same, EP or VP. So that is equal to minus D divided by dt of NP into phi. NP means number of turns in the primary coil. Okay, so this is minus NP into d phi by dt. Right? So call this as equation number 1. And EMF induced in the secondary coil, that is Vs, is equal to minus d divided by dt of Ns into phi. This is, so Ns is constant, that is stayed as outside, minus Ns into d phi by dt. So this is EMF induced in the secondary coil. So this is according to Faraday's second law of electromagnetic induction, right? So now equation 2 divided by equation 1 gives Vs divided by Vp, so that is equal to Vs divided by Vp, so that is equal to, so minus Ns into d phi by dt, so whole divided by minus np into d phi by dt, so d phi by dt, so minus minus cancels, so we will get ns divided by np. Okay, So this is also equal to, according to Ohm's law, so Vs is equal to Is into R. R is the resistance, or simply, actually here, power input is equal to the power output. Input power is equal to output power. That means Vp, power is the rate of doing work, W by T. So work done in terms of potential, that is Vq, right? So Q by T is I. So P is equal to Vi. So this is Vp Ip, and this is equal to Vs Vs Is. So Vs divided by Vp, so that can also be written in the form of Vs divided by Vp, that is Ip divided by Is. Okay, so Ns by Np, so this is also equal to Ip divided by Is. Actually, this is very important for CD. Vs by Vp, that is equal to, Vs by Vp is equal to Ip divided by Is, right? So this is actually the turns ratio. Ns divided by Np, so this is actually turns ratio. Okay, so the ratio of number of turns in the secondary coil to the number of turns in the primary coil is called the turns ratio. Okay, so if this is actually the first special case, if Ns is less than Np, then the turns ratio is less than 1. Number of turns in the secondary coil, that is less than the number of turns in the primary coil. Number of turns in the secondary coil, that is less than the number of turns in the primary coil. Number of turns in the primary coil is more than the number of turns in the secondary coil. So then the transformer is just behaves like step down, is it not? That is step down transformer. So if Ns is more than Np, then turns ratio is more than 1. So then the transformer is behaves like step up, right? Number of turns in the secondary coil is more than the number of turns in the primary coil. So then the transformer is behaves like step up transformer. Okay, so if Ns is less than Np, turns ratio is less than 1. Turns ratio is less than 1. So what is the value of Vs by Vp? So Vs by Vp, Vs by Vp, so that is also less than 1, right? If turns ratio is less than 1, Vs by Vp, that is less than 1. But Ip by Is, so that is also less than 1. So Vs by Vp is less than 1, and Vs is less than Vp. Okay, so in this case, Ip divided by Is, that is less than 1. That is why Ip is less than Is. So here the secondary voltage is less as compared to the primary voltage. Output voltage is less as compared to the input voltage. That means it decreases the alternating voltage by increasing the alternating current. Actually here output current, that is more than the input current. Input current is less than the output current, right? But in the case of step down transformer, step up transformer, turns ratio is more than 1. In the case of step down transformer, turns ratio is less than 1. In the case of step up transformer, turns ratio is more than 1. So if turns ratio is more than 1, so then Vs by Vp, that is more than 1. That means Vs is more than Vp. Okay. And Ip divided by Is, so this is also more than 1. That means Ip more than Is. So in this case, the output voltage is more than the input voltage. Secondary voltage is more than the primary voltage, but the primary current, that is more than the secondary current. Secondary current, that is less than the primary current, right? So step up transformer increases the alternating voltage, by decreasing the alternating current. Okay, step down transformer decreases the alternating voltage by increasing the alternating current. Okay, step up transformer increases the alternating voltage, by decreasing the alternating current, right? Okay, now let us discuss about the sources of energy loss or power loss in transformer. So the first one is, these are the sources of energy loss. So loss due to heating, loss due to heating, and loss that is due to flux leakage, flux leakage. So loss due to eddy currents, loss due to eddy currents. The last one is loss due to magnetic hysteresis, magnetic hysteresis. What is the meaning of magnetic hysteresis? The phenomenon of lagging of magnetic induction behind the magnetic intensity in the ferromagnetic material subjected to cycles of magnetization and demagnetization. Okay, so these are the sources of energy loss in a transformer. Loss due to heating. So actually this can be reduced by using thick wires with considerably low resistance. Thick wires with considerably low resistance are used to minimize this loss. Okay, so how to reduce the flux leakage? So flux leakage, so that can be minimized by using a shell type core, shell type core. Okay, so this loss that can be minimized by using shell like core, shell type core. So how to reduce the eddy currents? What is the meaning of eddy currents? So eddy currents are current loops developed in a conducting material, that is due to the varying magnetic flux linked with the conducting material. So how to reduce the eddy currents? So actually, due to the production of eddy currents, heat is produced in the mass of matter. so which results in the loss of energy, right? Due to the production of eddy currents, heat is produced in the mass of metal, which results in loss of energy. So this is one of the source of energy loss in transformer. Okay, how to reduce the loss, energy loss that is due to eddy currents? That is also very important. So that can be minimized by using a laminated core made of stelloid. Okay, so this can be minimized. This can be minimized by using a laminated core made of stelloid. Made of stelloid. Stelloid means an alloy of steel. An alloy of steel is called stelloid. Eddy currents, loss due to eddy currents that can be minimized by using a laminated core. Laminated core. Okay. So how to reduce loss that is due to magnetic hysteresis? So that can be minimized by using alloys. This can be minimized by using alloys like silicon steel. Okay, so these are some very important sources of energy loss and transformer, loss due to heating, loss due to flux leakage, loss due to eddy currents, loss due to magnetic hysteresis. So loss due to heating, energy loss due to heating, so that can be minimized by using just thick wires of considerably low resistance. The loss due to flux leakage, so that can be minimized by using shell type core. Loss due to eddy currents, that can be minimized by using laminated core. Laminated core. Loss due to magnetic hysteresis, that can be minimized by using alloys. Okay. What is the meaning of transformer? Transformer is a device used to vary the AC voltages and hence AC currents. Transformer works on the principle of mutual induction. So transformer is of two types, step up and step down. So actually this is step up transformer. Step up transformer increases the alternating voltage by decreasing the alternating current. Step up transformer increases the alternating voltage by decreasing the alternating current, right? Step down transformer decreases the alternating voltage. Step down decreases the alternating voltage by increasing the alternating current. Okay, step up transformer increases the alternating voltage by decreasing the alternating current. Step down transformer decreases the alternating voltage by increasing the alternating current. Okay, so the construction is very simple. It consisting of two coils. One of the coil that is connected to AC input, that is called a primary coil, and other coil is connected actually that is connected to the load. Other coil is giving output. So this is called the secondary coil. Both coils are wound on the same iron core, right? AC voltage that is applied to the primary coil. So what happens? The current flowing through the primary coil is gradually increases, so that the magnetic flux linked with the secondary coil is gradually increases. So whenever the magnetic flux linked with the coil changes, EMF induces. So actually here EMF induced in the secondary coil, that is due to the rate of change of current in the primary coil. So finally we will get the secondary voltage, that is ES or VS. So this is about the working of transformer. So what is the principle behind the working of transformer? It is mutual induction. And these are the sources of energy loss, loss due to heating, flux leakage, eddy current, and magnetic hysteresis. Okay, thank you.